Let's start off. There. So last class we have done with your average speed and all that stuff. Everyone need to keep your cams on. Yeah, everyone do make sure to keep your cams on. If your cams are not on, you'll be removed from the classroom. So let's go ahead before going ahead with uniform accelerated motion, which we'll be doing today. Let's do one more question. X is equal to t cubed by 3 minus 3t square by 2 plus 2t plus 1. X is the x coordinate of a particle. And t is the time. First question. Find distance traveled. In 3 seconds. We have done something like this before. Second thing, find the time interval when the particle is speeding up and speeding down. Don't worry about writing the notes. Focus on solving the question. You'll get the PDF end of the session. Find the time when the particle is speeding up. Look at the word. I'm not asking accelerating and decelerating. Speeding up means speed must be increasing, and speeding down, speed is decreasing. Let's get these two. If you got an answer, you should type in the chat box here to the co-host. There are 2 of my logins. Co-host is where I'm seeing you guys. So do type your answers to the co-host. Let's see how to do this. So we have a position of a particle which is t cubed by 3 minus 3t square by 2 plus 2t plus 1. Find the distance traveled in 3 seconds. This particle is going in a one dimension on x-axis. And find the time interval when the particle is speeding up and speeding down. Time interval, right, Vanshika? I'm not asking for how long it is accelerating. First, get the A part, everyone. How do you find the distance traveled? 2.5 meters. What are you calculating, right? Distance traveled. Hmm. 6 meters. You got such a good number. You just forgot how we did this. Again, let's talk about few things. Let's see how do you find the distance traveled. So x is t cubed by 3 minus 3t square by 2 plus 2t plus 1. Let's differentiate it first. So velocity v will be dx by dt. T cube by 3, that will become t square. T square differential 2t, 2t will cancel, you'll get minus 3t plus 2. This is your velocity as function of time t. Now, if I put v is equal to 0, I get t square minus 3t. So v is equal to t square minus 3t plus 2 is equal to 0. So you will get t is equal to 1 or t is equal to 2. There are two times when the velocity is becoming 0. Is that clear, everyone? So let's see what is actually happening with the path. At t0, where are you? If you put t0 here, what are you getting x coordinate? At t0, you're at x is equal to 1. So if I assume this is some kind of a block or a person here, this guy at t0, he's at x is equal to 1 and traveling forward. Next thing. So t is equal to 1 and t is equal to 2. So these are the points, where the particle takes a turn. Think about it. If you're walking in a straight line, if you go straight and if you come back, the moment you're taking a turn, don't you stop for a moment? Every time you take a turn backward, you always stop for a moment. So these are actually the turning points. This is the time when the particle takes a turn back. So this particle is going straight, and at t is equal to 1 second, where are you? At t is equal to 1, substitute here. How much are you getting? At t is equal to 1, x will be 1 by 3 minus 3 by 2 plus 2 plus 1. This guy will be 1 by 3 plus 3 by 2. That would be 9 plus 2, 11 by 6. So at t is equal to 1 second, you have reached a point 11 by 6, and then you come momentarily to rest. And then you turn back. Then you started turning back again. So the particle is going front and then it is coming back. Then when do you stop again? You again stop when x is equal to, when t is equal to 2. This will be 2 cubed by 3, which is 8 by 3, minus 3, 2 square by 2, that is 6, plus 2 into 2 plus 1. How much is this? 8 by 3 minus 6 plus 4 plus 1, 8 by 5 by 3. So this guy will go back somewhere till here. So you reach a point x is equal to 5 by 3 when your time is t is equal to 2 by second, 2 seconds. You're getting? And then again you come to rest. So this path, right, this guy is actually going front, coming back and going front. This is how the path is going on. You're going front, you're coming back, and then you're again going front. Then again you make a turn. Again you're going forward. This is the way to do. You literally have to calculate the whole path. The question asked was distance. What some people do, right? They put t is equal to 3, they'll get x coordinate. They'll put t is equal to 0, they'll get the initial coordinate. And if you subtract x final minus x initial, you get displacement. You don't get distance. I hope everyone is clear with distance and displacement. All right. So let's finish all this. So you are taking a turning here, and again you're going this side. So where are you at t is equal to 3 seconds? At t is equal to 3 seconds, your x coordinate will be 3 cubed by 3 minus 3 by 2, 3 square plus 2 into 3 plus 1. How much is this? That's 9 minus 27 by 2 plus 6 plus 1. That's 16. 16 minus 2, 32 minus 27, 5 by 2. So there at t is equal to 3 seconds, you reach x is equal to 5 by 2. So what is the total distance? The total distance will be this length, and this length. Is that making sense, everyone? Any doubt so far? Anyone not clear with any particular step? You can just always unmute and ask me that out. So You're done. So distance traveled. So when you went from 0 to 1 second, you traveled 11 by 6 minus 1. Then when you went from 1 to 2 seconds, you traveled from 11 by 6 to 5 by 3. Then you traveled from 5 by 3 to 5 by 2. 5 by 6. That would be 1 by 6. This would be 5 by 6 again. This would be 1 plus 6 by 5, 11 by 6 meters. Yep, that's your answer. This is your distance. Some people will do this thing. If you want displacement, then you just find the x coordinate at 3 seconds and this thing. So displacement will be 5 by 2 minus 1. That would be 3 by 2 meters. You just take the final coordinate, initial coordinate, subtract. That will give you displacement. The question asked was distance traveled. Is the steps clear, everyone? Don't you guys remember we have done this in calculus? Most of you forgot. The moment they ask you for distance, remember it's a trap. You have to be careful. This is the way to do. You literally have to draw the path and see where you are at each turning point and then find the total thing. It's a good question. Do have a look at this. If you just find the x coordinate at 3 and x coordinate at 0 and subtract them, you won't get distance, you'll get displacement. Shreyan, Utsa, you need to guys keep your cams on or else you'll be removed from the classroom. All clear with this thing. Question still not over. Samyak, I think you got something. The main part of the question is this: find the time when the particle is speeding up and speeding down. What do you mean by speeding up and speeding down? Any doubts on the distance? This would be a decent mains level question. If I ask you speeding up and speeding down, I can make it a more than one choice question in advance. So before jumping in, let me explain you what is speeding up and speeding down. If you have a vehicle or a particle, let's say if your acceleration is forward and velocity is forward. So if both A and B are in the same direction, we say it is speeding up. So look at here. Acceleration is positive. So don't get confused between positive acceleration and negative acceleration. Acceleration is in positive x-axis and the particle is speeding up because the speed is increasing. Suppose acceleration is forward, but the velocity is backward. Acceleration is still positive because it's in the forward direction, but the particle speed is decreasing. So we call this thing speeding down. That's it. So if your speed increases, you're speeding up. If your speed decreases, you're speeding down. Suppose your acceleration and velocity both are backward. Your acceleration is negative direction, minus x-axis. But since A and B are in same direction, the speed increases in the negative direction, so speeding up. There, that is the idea there. If A and B are in the same direction, it is speeding up. If A and B are in the opposite direction, it is speeding down. So here acceleration is negative, but the particle is slowing down. This is in one-dimensional. If you go for 2D or 3D, right? In vector form, if A bar dot V bar, the dot product, if it is greater than 0, then the particle is speeding up. If A bar dot V bar is less than 0, then the particle is speeding down. If the angle between them is obtuse, then the particle speed will decrease. If the angle is acute, the particle speed will increase. So this is a vector form. If someone asks you in 3D, this is how you do. In 1D, it is easy. Just look at the direction of A and B. This is speeding up and speeding down the concept. Is this clear, everyone? So you can have an acceleration in the forward direction. You can still be speeding down because V is backward. So if A and V are in same direction, we call it speeding up and opposite speeding down. Is this concept clear, everyone? Now can you solve the question? Find the time when this particle is speeding up and speeding down. Let's get this. I'll give you a minute or two.
Sir, can it also be expressed as the interval in which the double derivative has the same sign as the derivative?
So isn't that simply acceleration and velocity what you're talking about? You
Yes.
just made it look more mathematical. So yeah. We simply call it acceleration and velocity. You call it double derivative and first derivative.
Yes.
How do you find this, everyone? Find the time interval when the particle is speeding up and speeding down.
So we can find the acceleration, then input the values and find whether
Yeah. So
we
get
can
that and
plot.
get me an answer, Shreyan, and you can type your answer here. I want an answer. Explanations, I know most of you understood the thing. So solve and get me an answer. You got 2 minutes for that. Get me an answer to put in the chat box. You didn't understand something, please ask. Question is clear, you got 2 minutes to solve. You already have one answer. Samyak got it. One to two speeding down. You have to give me the full interval. You maybe got just part of an answer. You already know the velocity. That's not the complete answer, Param. That's not a full answer. So we know velocity is t squared minus 3t plus 2. This is t minus 1 and t minus 2. Acceleration is dv by dt, which is 2t minus 3, t minus 3 by 2. Now see, if you look at the velocity here, so let's divide the whole thing into 3 pieces, okay? t0 to t1, t1 to t3 by 2, t3 by 2 to t2, and then ahead. So first look at the velocity. So when you go from 0 to 1, from 0 to 1, t minus 1 is negative, t minus 2 is negative. Both are negative. So velocity is positive in this region. But look at the acceleration. When you go from 0 to 1, acceleration is negative. Are you getting what I did? If t is less than 1, so this is a time interval between 1 to 0. T minus 1 is negative, t minus 2 is negative. Negative into negative is positive. But acceleration will be negative. If you go from 1 to 3 by 2, t minus 1 is positive, t minus 2 is negative. So velocity is negative in this region. So that is between t 3 by 2 to 1. And your acceleration would be less than 3 by 2. That is still negative. And between 2 to 3 by 2, your velocity is still negative. Because t minus 2 is negative, t minus 1 is positive. Your acceleration has become positive. And if you go for t greater than 2, that is still infinity. Velocity is positive and acceleration is also positive. That you can clearly see now. You are speeding up here. So 0 to 1, A and B are opposite, so speeding down. Speed decreases. Speed increases. Speed decreases and speed increases. So speeding down will be time interval from 0 to 1, union, and then 3 by 2, comma 2. Speeding up will be 1, 2, 3 by 2, union 2 to infinity. These are the time intervals when they accelerate and decelerate. Is this making sense? So you just need to find when velocity is positive, find the time when acceleration is positive, and take a common interval between them and finish it off. It's a pretty good question. It can be a good more than one choice question. You can ask a lot of things in this: distance, displacement, speeding up, speeding down. Find the time when find the time when find the velocity when a is zero, all that kind of stuff. So all clear with this?
Sir,
Advai.
I did not exactly understand how did you find out acceleration velocity are positive or negative?
You should just substitute the values and check here. Don't you know how to do this thing? T minus 1 and T minus 2. If T ka value is between 1 and 2, what will happen? This number is positive and this number is negative.
So you just substitute the values of t into that.
Yeah, and just check there whether it is positive or negative.
Okay.
Clear with this? Otherwise, I think you can just restart and see. Everyone can see the screen, right? Otherwise, I think only you're having an issue. Just restart once. Sanskriti, you'll be removed from the classroom if you don't keep your cam on. So great. So that's a bit about this one. Next thing, uniform accelerated motion. So till now we have done distance and displacements. And average velocity, average speed, and all that stuff. So when you say uniformly accelerated motion, it simply means you're taking a constant acceleration. Right? So u is your initial velocity. V is your final velocity, or velocity at time t. And we actually did this derivation before. I'll just show it to you very fast. So acceleration a is dv by dt. You're taking a as constant. This will be dv. This will be a dt. Integrate on both sides. Limits will go from u to v, and this will go from 0 to t. This will be v minus u is equal to at. This is your first equation for uniform motion. V is equal to u plus at, which you studied in school. If I integrate this again, v will be dx by dt, which is u plus at. This will be dx, this will be u dt plus at dt. Integrate on both sides. This will be from x initial to x final. This will be from 0 to t and 0 to t. This will give me x final minus x initial is equal to ut plus half at square. Final minus initial is nothing but displacement. This is your second equation. S is ut plus half at square. So these equations were derived under the assumption a is constant. If a is not constant, don't use them. And then we also know acceleration is equal to v dv by dx. So this can be integrated. So v dv is equal to a dx. Integrate on both sides. This will be u to v, and this is x initial to x final. This comes out to be v square minus u square by 2 is equal to a into x final minus x initial. This is v square minus u square is 2as. This is your third equation. All got this? So they are the three equations which you use when a is constant. If a is not constant, don't use them. Any doubts on this? We have done this before in calculus. Same question. We derived this before also. Then we did it how for variable things also we have derived in calculus. So you have seen this stuff. Any doubts on this page? Great. Next thing. So we will follow a sign convention. And this is a sign convention we'll follow for the entire mechanics. We'll keep it a simple one, your Cartesian coordinate system. So anything that goes up is positive, down is negative, right is positive, left is negative. Example, if someone comes and tells you this guy is going with an acceleration of 2 meters per second square towards right, and it is having a velocity u is equal to 10 meters per second. So while applying the formulas, you will write u is equal to minus 10 because it is going back, and a is equal to plus 2. So while applying the formulas, make sure you have appropriate signs. Suppose if this thing is going up with 5 meters per second, and acceleration is down, which is 2 meters per second square. So when you apply the formulas, you use u is equal to 5 and a is equal to minus 2. Clear? Simple sign convention, up positive, down negative. Anything that is pointing right is positive, anything that is pointing left is negative. Clear with this? So today we'll be just playing around with these three equations. Any doubts on the formulas or the sign convention, please ask me. Advai, clear? Utsa? Yashvi? Great. Let's see a question. We have a vehicle here whose speed here is 20 kilometers per hour. This is point A. This is B here. When the vehicle reaches here, let's call it C. So VC, the speed becomes 30 kilometers per hour. There's a point B somewhere in the middle where AB by BC is in the ratio of 1:3, meaning this distance and this distance are in the ratio of 1:3. So we got a vehicle which is moving with constant acceleration. How much? That is not mentioned. All we know, it is a constant acceleration. Has speed 20 kilometers per hour at A and 30 kilometers per hour at C. And AB by BC is 1:3. First question, find the speed at B. It's going in a straight line. We are just doing 1D for now. Second question, find the ratio of time to go from A to B by time taken to go from B to C. Let's get them. Advait, you can see the screen now. Yeah. Get this, it's a decent one. Anyone not clear with the question, please ask me. I'll explain the question again. Question is clear, go ahead, you got 2 minutes. We have a vehicle which is going with a constant acceleration A from A to C. How much is the acceleration? Not given. At point A, the speed was 20. At point C, speed was 30. AB by BC is 1:3. Using this information, find the speed at B and find the ratio of time from A to B and B to C. Any ideas for the speed? We have root 525. Ishman, that is wrong. Samyak, Shreyansh, I think yeah, both of you got the speed right. Arya, I think you goofed up. देखो ना Arya, logically switch. The answer you got is greater than 30.
I'm sorry, I did a calculation mistake.
Ah, Ishman, right. Get the B part also. You got an answer, you can type in the chat box to the co-host. Remember, there are two of my logins. One is the co-host, so make sure to type there. I can't see the other one. So if you got an answer, do type. So that's how I know you're getting it. In case you didn't get it, that is completely fine. Give your best. Anyway, I'm going to explain it. Let's see the first part. Now see, when you see a question, right, normally, I know I have to use the three equations, but which equation should I use? So this is something important, right? You know, it might look like obvious, but you need to develop the skill. When you see a question, you need to understand how do I even start? I have three equations. V is equal to U plus AT. Now look at the question ka data. This data is saying if this is S, this is 3S. So they're talking about distances. They're talking about initial speed. They're talking about final speed. One thing they're not talking is time, isn't it? That means using V is equal to U plus AT doesn't make sense. There is no time only. Using S is UT plus half AT square doesn't make sense. There is a time. So the only equation left is V square minus U square is 2AS. You're getting? So that's how you get an idea, boss. I think I should use this. So let's use for A to B. So when you're at B, the speed is VB. So we are using the equation V square minus U square is 2AS. So V is final. So here it is VB square minus VA square. Acceleration I don't know. So let it be A and let it be S. When you go from B to C, same story. V square minus U square is 2AS. So this will be VC square. So B is the initial. This will be 2A, 3S. Equation 2, equation 1, just divide them. Or just take this guy and substitute here. You will get VC square minus VB square will be 3 times 2AS, which is VB square minus VA square. You want to find VB, bring it to one side, you end up with VC square plus 3 VA square by 4 ka root. There, that's your answer. You can put down the values and check it out. VC, VA ka values, everything, you know. How much you guys got? You got 5 root 21, it seems. So maybe that's the answer. You can check it out.
So can you show the question, please?
Next is time. A to B and B to C ka time. Any doubts on this page? Please ask me. Times, let's see, might be right. Now, once you got this actually time, you'll get it. Let me just show it in the next page. But any doubts on this part?
So we can solve this using ratios also, right?
What ratios?
Or we'll take the ratio of the two equations.
Same thing, na? Substitution ratio, sub same here. We're just using some different thing. The same thing. How do you find times? So we'll use V is equal to U plus AT. So VB minus VA will give you acceleration and you'll get time from A to B. VC minus VB will give you acceleration time from B to C. Divide them. So you'll get time from A to B by time from B to C will be simply the ratio of velocities. VB minus VA by VC minus VB. I know all the three values. You substitute it from here. Take it and put it there, you'll get the answer. Is that clear, everyone? Once you got the final velocities and you know the initial velocities, you can get the time from there. We don't need Eka value because all I'm asking is the ratio there. Easy? So if you substitute this guy would be 5 root 21 minus 20 by 30 minus 5 root 21. That you can simplify this further. You can leave it there. Any doubts on this? Siddesh, clear with this? Tanishka? Shreyansh? Advai? Clear? Aditi, got this? Kartika, clear with this? Yes? Yeah. I'm looking at you guys on the screen, so you can just nod if you're understanding it. Next one. Let's do an easy one. So we got a vehicle here. T0, initial velocity U, acceleration A. The vehicle has initial speed U and acceleration A. Find a ratio of distance traveled in n seconds and nth second. Both are completely two different things. Meaning, just to give an example, if someone says 3 seconds, meaning you're talking time from 0 to 3. If someone says third second, look at this. When you go from 0 to 1, it's called first second. 1 to 2 is called second second. 2 to 3 is called third second. So that's the difference between 3 seconds and third second. If I say 3 seconds, meaning 0 to 3. If I say third second, means 2 to 3. Are you getting the difference? So that's how you count it. So be careful with that wording there. More of an so 0 to 1 is first second, 1 to 2 is second second, 2 to 3 is third second. So I'm asking you find the ratio of distance traveled in n seconds and nth second. Let's get this. There, in case you have a confusion, what is n seconds and nth second? So be careful with that wording. I hope that was clear. What is third second and 3 seconds? Yeah. Aditi, Advait, adjust your cams a bit. I can't see your faces. Utsa, please make sure your faces are completely visible on the screen. Mm, 2un n square. Yeah, something of that sort. Right, Arya, we have one answer. Right, Samyak. Neshman. Or maybe you simplified it, I guess. You didn't get U only anywhere in the denominator. You can't cancel U, Reshman. Something went wrong. Check. राइट वंशिका बट उसको थोड़ा सिंप्लीफाई कर सकते हो हाँ that's okay Ashwan. Try another 30-40 seconds. Decent one. It's like a decent means level or a CD type question. They might give numbers. We're just doing in variables. Let's see. Right, Param. Shaunak, I think so. Yeah. Let's see. So you want distance traveled in n seconds. We are going to use the formula S is equal to ut plus half at square. Because you gave me time, you gave me velocity, and you're asking for this. So if you want to find n seconds, that is easy. Just put t is equal to n and you'll get it. So Sn will be un plus half an square. But you want to find for nth second. So let's find for n minus 1 also. So this is the logic. I'll find the distance for n seconds. I'll find the distance for n minus 1 seconds. And if I subtract them, I'll get the nth second. So this will be half a into n minus 1 square. You're getting the logic? I'll find the distance for n seconds. I'll find the distance for n minus 1. If I subtract them, I'll get the nth second ka balance. Is that making sense logically? So the nth second will be Sn minus 1. So this guy will be u plus half an square and half an square will cancel. You will be stuck with an into n minus half. There. If you simplify this, that's what you'll get. So you can treat this as a formula for nth second, but yeah, you can always derive this, not a really super formula there. So you're done. So you're asking for n seconds by nth second. Divide them. So you'll get un plus half an square. U plus a by n minus half. The reason I don't like to remember this is because I can ask a question like this. Find the distance traveled in the 7th half second. Can you tell me what is the time interval? 7th half second.
Half, right?
Hey, 7th half second. Matlab which time interval is that?
6.5 to 7.5.
0 to half is first half second. You're getting it? 7th half second means you're counting time intervals in half of second now.
3.5.
Something like that. So 0 to half will be the first second. Second half second. 1.5. 2. 2.5. 3. 3.5. So this will be like 1, 2, 3, 4, 5, 6, 7. 3 to 3.5. You're getting it now. Then this formula won't be valid because this formula you derived for 1 second. So be careful with that. So have the basic idea. Is this clear, everyone? Easy, simple. Any doubts on this? Shreyansh, Sudiksha, clear? Shaunak, Alok, clear? Next one. Let's do something a little different. So we have two trains. Uniform accelerated motion, it's kind of little fine. We really don't have two tough things. Projectile is the one where we'll find more. But it is important we do everything. So we have two trains A and B starting from rest. And moving on parallel tracks. With acceleration A1 and A2. So the train A is going with acceleration A1, train B is going with acceleration A2 for time t. So after time t, A and B will exchange their accelerations. So after this time, A and B accelerate with A2. So A goes with A2 now and B goes with A1. So basically the accelerations are exchanged for the next time t. Meaning think of like this. For the first 1 hour, A is going with 2 meters per second square, B is going with 3 meters per second square. Next to 1 hour, A goes with 3 and B goes with 2. You're getting it? So for the first time t, you go with A1 and A2. Second time t, you go with A2 and A1. You interchange. So this is your A and this is your B. So initially this guy is going with A1 acceleration, A2 starting from rest. After some time t, now we don't know who is bigger. After this time t acceleration, this guy becomes A2 and this becomes A1. Both got interchanged. Find the ratio of distance traveled. Find the ratio of SA by SB in total time 2t. The trains are traveled for total time 2t. Second thing, find the maximum and the minimum value of SA by SB. SA is the distance traveled by train A, SB is the distance traveled by train B. Find the ratio of SA and SB in time 2t, and this ratio, what is the range or maximum and minimum value? Let's get this. If I just ask you the first question, it is still a mains one. If I ask you the second one, suddenly it bumps up. It would go to an advanced question. Maybe a more than one choice. Still a simple one in advance. But let's get this. It's a good question though. I hope the question was clear. There are two trains on a parallel track. Initially, for the first time t, A is going with A1 and B is going with A2. After time t, both the trains started going with different acceleration, A2 and A1. So total time of travel is 2t. Find the ratio of distance traveled in 2t and find the maximum and minimum value of SA and SB. Matlab, Vanshika, think of like this. A is not constant for the full motion, but it is constant for first time t. So as long as A is constant, you can use the equation till that point, isn't it? So you can say like this, I can't use the formulas from 0 to 2t, but I can use the formulas from 0 to t separately and t to 2t separately. I can do that. Right, Shreyansh. Can you get the ratio of that also, second part? Anyone else got the first part? Try. I'll give you a minute for the first part. Then second part, you can take another minute. First and second are kind of related. So Arya, I think you goofed up. Samyak, you got it. We have two answers. Shreyansh and Samyak. Ovia, you also got it. Got the first part. Get the second part. By any chance, anyone got 1:1? That would be a classic trap. I mean, general feeling, right? You get a feeling, yeah, it should be 1:1. All you're doing is just exchanging acceleration. So how can it get affected? Advay, question is clear. Aditi, question is clear, right? Srihari, Pratyasha. Let's see the first part, everyone. Let's look at train A. So A starting from here, your initial velocity is 0, your acceleration is A1. You're traveling for a time t. This is what I keep telling you, always draw a picture. Most of you think like, without a picture, I will get the answers. You need to put a picture for each and everything, even though it looks, useless. That is how you develop your ability to analyze and think. You might think it's a waste of time, but trust me, as you go on, you will have a big problem. As the later on problems become complex, right? You are not training your mind in how to visualize things. Trust me, if you can't draw a picture, means you didn't understand the question. there is a high chance going ahead you will go for physics big time. Anyone who has done physics, you'll observe they'll put pictures. Put a small thing for your visualization. Until unless you have some super photographic memory types or something. But yeah, zero nahi hai re. How can you get zero? Let's see. So what is the first part? S is ut plus half at square. You see every question that I'm doing, I'm putting a small picture. You can just do it in your head, but there's a high chance you'll goof up. So this is the thing. The most common mistake what people do is this. After time t, your velocity is not zero. You have gained some speed. V is equal to a1t. And your acceleration has become a2. Are you getting this? So the second part of the motion, the part vehicle ka speed is not zero. You're already having some initial speed now. That is a mistake what generally people do. They think it is zero. So time 2t. So when I do this for the second part, s is equal to ut plus half at square. So your initial velocity here is the final velocity in the first part. Are you getting what we did? We split the motion into two parts. So 0 to t, I'll use the kinematics equations because a is constant. I'll use from t to 2t kinematics equations. So the final velocity in the first part is the initial velocity for the second part. So the initial speed in the second part is a1 into t plus half a2 t square. This would be the total distance traveled by a. Add both of them. Right, what? So you got the minimum value, right? Nee, a1, a2 are constant, but you can take whatever constants you got, na? Put any value of a1 and a2. What is the range of that? That is the meaning of it. I hope this first part was clear, everyone. The most common mistake people think the velocity is zero here in the middle. So no, that is the thing. So if you look at B, same story, U is zero. This is A2, so this distance will be half A2 t square. By here, you must have gained a velocity A2t, so speeds are different. This guy will be A2t, that is your initial velocity, into time plus half A1t square. There. So SA by SB, just add this up. If you add this and this, you will get SA. How much is that? A1t square, A1t square, 3 by 2 A1t square plus A2t square by 2. By SB, same thing, add these two. This would be 3 by 2 A2t square plus A1 by 2t square. T square and 2 goes off, you get a neat ratio 3A1 plus A2 by 3A2 plus A1. There. Nee, Vanshika, see na, you're going from T to 2T. So what's the time interval? In the formula, V is equal to U plus AT. T is the time interval, isn't it? Is that clear? I mean, if that's confusing, you can do something like this. You can say for the second part, this is T0, this is T na, for the second part. Got it? So don't take 2T there. That's a time interval. Clear? How do you get the ratio here? Samyak got it. Utsa got it. We have two answers. All clear with this function? Now, this is just a little mathematical thing. So we got SA by SB 3A1 plus A2 by A1 plus 3A2. So the meaning of this is you can put whatever values you want here. So I can write this thing as, take out A1 common. So you'll get 3 A2 by A1 by 1 plus 3 A2 by A1. So if I take A1 is tending to infinity, means I'll take a very, very large value. If A2 tends to infinity, or if I can say A1 is much, much greater than A2, then what will happen? A2 by A1 will tend to 0. If you take acceleration A2 very, very large compared to A1, then the ratio A2 by A1 will almost tend to 0. Then you get the ratio SA by SB will get close to 3. You'll never reach 3. You'll get closer to 3 because A2 by A1 will never be 0. It will get closer to 0. Similarly, I can write this thing in another way. This time take out a2 common. Then it will be 1 plus 3a1 by a2 by 3 plus a1 by a2. Now this time I will assume a2 is much greater than a1, means a2 is very large value. That means a1 by a2. See, if you're dividing a value with a large number in the denominator, you'll get very close to 0. This will give you a ratio SA by SB tending to 1 by 3. So if you combine these two, we will get SA by SB ka ratio. It cannot exceed 3. It cannot go below 1 by 3. This value has to lie between 3 and 1 by 3. No matter which values you take. You put any numbers you want. You take A1 is equal to 1 and put A2 is equal to like 10 lakhs. The numbers can't exceed 3 and numbers can't go below 1 by 3. You put any numbers you want. This is how you get a range. So we'll assume extreme values for A1, A2. Is this clear, everyone? That would be a good integer question. And the best thing about this question, there is not a single number in the question. A1, A2, T, 2T, there's not a single number, but I can still make an integer out of it. Find the maximum range of SA by SB. Is this clear, everyone? Like I said, this is more of mathematics than physics. Physics got over with this question. So you will never reach 3. So it is less than or equal to. Equal to nahi aayega. All clear with this? Let's see one more. Any doubts on this? Again, we are just playing with the 3 equations.
Sir, if it never actually reaches 3, what will we write the maximum value as?
It will tend to 3. So technically, you should not be asking it. You can say upper bound. We don't say maximum value.
Okay.
It's bounded by 3. Next one. We have a wooden plank. So someone shot this with a bullet with speed u. When the bullet comes out, it comes out with a speed 9u by 10. A bullet passes through a wooden plank. And loses 1/10 of a velocity. Right? Assume constant deceleration. So when you're going through the plank, assume there's a constant deceleration. How much, we don't know. This is the only information we have. If you send a thing through a wooden plank, you're losing 1/10. So the question is, how many planks do I need to stop the bullet? Another standard question. Meaning, if I'm going to put a bunch of planks, identical planks, 1, 2, 3, so on till n, and if you fire this, I want the bullet to come to rest. So basically, I'm asking you find n. Question is clear? You took one wooden plank, and when you fired through this, same bullet, same gun, so the speed you lost 1/10. Assume constant deceleration. If you take n planks and if you keep them, and when you fire them, the bullet stopped after n planks. Find n. Right, Ishmael. No, Advai. That is wrong. I know you get a feeling like maybe it could be 10. It's not 10. Right, Siddesh. Try others. Right, Samyak. Got an answer, you can type in the chat box. Anyone else? Any other answer? I want an integer, yeah. If I say how many apples you have, you won't say 95 by 3. You don't get a fraction of apples. Listen. So let's take one plank. Let the width be d. I don't know this. Let this guy go with speed u. It comes out with a speed 9u by 10. So I'll use the equation of kinematics. V square minus u square is 2as. So v is the final speed. So 9u by 10 whole square minus u square is 2ad. D is the width of the plank. This is 1. Now you have taken n planks. That means this width will be n into d. So the bullet enters with the same speed u, but at the edge it stops at v0. Again, I'll use the kinematics equation. Now the speed will be 0 square minus u square will be 2a/d. This is equation 2. You can divide them or you can just substitute there. So this will be how much? Take out u square common. That would be 81 by 100 minus 1 is equal to 2ad. Division. So this will be 0 square minus u square. That will be minus u square by 2a/d. I am just dividing equation 1 by 2. U square goes off, and this will be 1 minus 1 by 100. So that would be 19 by 100 is equal to 1 by n. So we get n is 100 by 19. This is around 5. 19 5 is this thing plus almost half, something like that. You get a fraction there. Just keep it as n. It doesn't matter. It will cancel out anyway. A is just a variable, right? So this thing approximately comes out to be 5.25, something like that. Meaning we need 5 planks plus we need at least a 1/4 of a plank. So we need 5. If you use only 5 planks, the bullet won't stop. So I need 1/4 of a plank, but you can't use 1/4 of a plank. Therefore, you are actually using 6 planks. Isn't it? If you used a part of the plank, that is also, you consider the full plank. Yeah, we did something like this in foundation. Is this clear, everyone? So we need 6 planks to stop the bullet. So if you get a fraction like, let's say if you got 6.01, the answer is 7. If you exceed the number, means you take the next integer. Because exactly 6 planks won't stop the bullet. You'll still come out with some small speed. If you get 5.99, answer is 6. Clear with that? You take the next greatest integer. Any doubts on this? Clear? Good one. Take a small break. Come back by 9:40. 5 minutes. You continue from here. Any doubts so far? Anything you're not clear, please ask. If you're clear, you can take a break, come back in 5 minutes. Okay, come back in 5 minutes.
Sir,
Let's go ahead. Next one. Let's do something different. Others, keep your cams on. So this is a top view you're seeing from a drone or something. So we got a railway track here. We have point A here, and we have a train. Let's say there's a train giving out smoke. This is the scenario at t is equal to 0. This is point B. This is point C. This is perpendicular. This distance here is 400 meters. This distance here is 300 meters. And we have a person here standing at C. So we have an observer here. Now what this train does, so the train starts from rest. With acceleration A is equal to 2 meter per second square, right? And it blows a siren, it blows a horn. Or a siren till it reaches B. look at the scenario. The train is starting from point A. So when the train starts the engine, the driver, switches on the siren. So there's a, big sound, and he does this till he reaches point B. Ignore the length of the train. Getting it? And the speed of sound, for convenience, we'll take it as 300 meters per second. In reality, it is 330, but let's take it 300. So the question is this. Now we have an observer, on the side of the track at a distance of 300 meters perpendicular to the track. Are you getting the picture here? This is the top view. So the observer is standing somewhere here. So the question is, for how long did the observer hear the siren? You can listen to the story. The train starts at point A with an acceleration of 2 meters per second square. Initial velocity is 0. In this process, the driver switches on the siren from A to B. At point B, he switches off the siren. The question is, for how long did this observer hear the siren? You remember, Ishman, we did this in foundation. So let's see others if you remember. It's a good one.
Does this involve calculus?
नहीं रे. I am teaching a uniform accelerated motion. यहाँ पे calculus कहाँ से आएगा? Calculus के लिए तो I would have said A is equal to changing with time and all that stuff.
No,
Think.
like
It's a good
the
one.
sound is coming from
You can do whatever you want. This is the question. That's it. After 2 minutes, I'll explain you. Till then, you have to try on your own. The time you get is for you to think. It is okay if you don't get an answer. Get a wrong answer. That is completely fine. But use the time to think. Samir, you got it. We have 2 answers. Yeah, we have done this in foundation, so some people do have an idea. But others try. I'll give it 2 minutes. It's a good one. Right, Pratyasha. I should have changed the numbers, I guess.
Seven steps that we
9.33. 19. So what is the catch here? How long will the train take to go from A to B? 20 seconds, right? That means siren is on for 20 seconds. No, obvious. You got 2 less, right? So siren is on for 20 seconds. So the question comes this way. If the siren is on for 20 seconds, shouldn't the person also hear for 20 seconds? But there is something here. Right, Shriyansh. Yeah, that is also right, Shriyansh. So what is the catch? Why is this guy hearing not 20 seconds? He is hearing something else. Nee, Arya. Listen to the story. This is what is happening. So this observer who is standing at C. So when the train starts at point A, the sound which is released, now see, the sound will immediately not reach the person C here, isn't it? This distance is 500 meters. Pythagoras theorem. So the sound which was released at t is equal to 0 reaches the observer at 500 by 300 seconds. That means the first time he will hear the sound, the time will be 5 by 3 seconds. So get this thing. The sound was released at t0, but he won't hear the sound at t0. He will hear after 5 by 3 seconds. You're getting the catch? So the first time when the engine driver, started the horn, the guy doesn't hear the sound immediately. It takes there's a delay, 5 by 3 seconds. Finally, when the train comes to point B, now this sound will travel this way. Now the catch here is you're traveling less distance. How much was this? 300 meters. That means the sound which was released at 20 seconds, that was the last sound. The sound released at 20 seconds reaches the observer after 1 second. That is 300 meters by 300 speed. 1 second. That is, he hears the last sound at 21 seconds. Is that making sense? The sound which you released at t0, you will hear at t is equal to 5 by 3. The sound which you released at t is equal to 20, you will hear 20 plus 1 second. It will take 1 second for the sound to travel from B to C. So the time interval which he will hear, so the catch was this. Initially the sound traveled 500, now the sound traveled 300. Because the train came closer, the sound has to travel 200 meters less. That messed up the timing. If the train had been at the same place, the sound would have traveled 500 meters in all the cases. The time would have been 20 seconds only. Because the train came closer, the time interval for the sound is less. So you feel as if you're hearing it for lesser time. So the time interval he hears. So this guy started hearing the sound at 5 by 3 and stopped at 21. So 21 minus 5 by 3. He heard the sound for this much time. How much is this? 63 minus 5. 58 by 3 seconds.
19.44.
Yeah, something 19 point something you'll get. Clear with this? This is definitely less than 20 seconds. Is this making sense, everyone? If the train was actually going away, this guy would have heard the sound more than 20 seconds. Clear with this? Again, I didn't use anything. We just use a little kinematics and little sound. But there.
So could you explain about 21 again? I didn't get them.
When did you leave the last sound?
At 20th second,
20 seconds. From B to C, what is the distance?
300 meters.
What is the speed of sound?
Okay, 300 meters.
So 1 second extra, right? So time taken for sound from B to C is 1 second. So the sound was released at 20 seconds, but it took sound 1 more second to travel. So you heard the sound at 21st second. Is
Okay,
this
but
clear,
then,
everyone?
how do we know that at like t equals to 1, 2, 3, it'll also be more, it'll take more time, right? So how do we count?
Fair.
Like t equals to 1 पे भी 1 second से ज़्यादा लगेगा ना? तो
Yeah.
so won't we bring all that into consideration?
You should try and see then if you feel that way. I think you should take at a distance x and then you try to find the sound and then you have to do maximum minimum.
Okay.
But I don't think so that'll happen because the train is actually going pretty slow compared to this. It should work out. Yeah, I know what you're saying. There is a possibility, but yeah, that's not the thing here. In this case, it won't happen.
Okay.
Clear with this? But got the idea here, basically what we're saying, the first and the last sound.
Yes.
Let's see one more. top view. We have a wall. We have a vehicle going with an acceleration a, initially u is 0. So this vehicle goes parallel to the wall. The distance between the wall and the vehicle is d. So car starting from rest, moving parallel to the wall. With constant acceleration a. At t is equal to 0, the car sounds a horn. Only once. At t0, the driver just honked the car once. That's it. It's not like a siren. You just made the horn once and then left it. Speed of sound is c. So after what time does the driver hear an echo? You know what's an echo, right? The reflection of sound on the walls. So this guy sounded a horn at t0. That sound goes and hits the wall and bounces. So you get everything in variables. After what time does this observer hear an echo? For the previous thing you're asking now, because the vehicle is traveling too slow, right? It's not going really fast. Even after 20 seconds, the speed is how much? 40 meters per second. So what you're asking, that by the time this thing tries to go from here to here, the sound must have traveled a lot of distance.
Yes.
The scenario which you would have asked would have happened if the vehicle speed exceeds 300 meters per second.
I didn't get that.
Nah. See, if the vehicle itself is going faster than speed of sound, then what you're asking could have happened.
So if vehicle, yeah.
If the vehicle is here and let's say the vehicle is going at 400 meters per second, by the time the vehicle goes here, sound has traveled only this much.
So
But
what I
because
was
the
saying
vehicle is
was
going slow,
from t equals to 0 onwards,
Mhm.
to some point it will still take it more than 1 second to reach that.
Yeah, that is there now. But see, you have to count the total time, right?
Oh,
When
okay.
this vehicle come here, you have to count this time also, isn't it?
Yes.
This time plus this time, na?
Okay. Okay. Yeah. Go.
Got it. So when you're at B, your train has already traveled 20 seconds. Then it took one more second. So you count 20 plus 1.
Okay.
Got it. I agree with what you're saying. The time will keep on decreasing. But you have to include the time taken by the train to travel till that point.
Right.
How do we do this? 4C by A. Someone got such a beautiful answer. I don't think so. You won't get a good answer. I can even ask another question. Find the condition if the man can never hear an echo. This is the top view. There is a wall parallel to this thing. The distance between the vehicle and the wall is D, and the vehicle is going in a straight line parallel to the wall. Let me tell you one thing. When you sounded the horn, the sound which will go here, do you think he will hear this sound? By the time the vehicle is already gone ahead, isn't it? So sound also obeys principle of reflection. So I'll just give you an idea. So sound must be traveling like this. It must have hit the wall somewhere here. It must have bounced here. So when the sound reached here, the vehicle must have reached here, isn't it? So when the sound has traveled this way, the vehicle has gone straight this way. So that is how he must have heard the sound. Are you getting the catch question now? Now try. I'll give you 2 minutes. How do we approach this? You get a biquadratic. Matlab power 4 quadratic equation, which is still solvable. Cubes are painful, but biquadratics are solvable. Let's see the picture. Like I keep saying, if you can't draw a picture, then most of the times you won't get the questions. Most of the times. Take it as an experience, from a person who has cracked the exam, not like a teacher. I have seen people thinking, without a picture, I will get it. You are just living in an illusion. Or maybe you can really see things in space. So the sound must have traveled like this, and the sound must have gone like this. So this thing obeys principle of reflection. So this angle and this angle must be equal. That's the first thing you need to know. Sound obeys law of reflection, just like light rays. So the angle of incidence is equal to angle of reflection. So, and how much does this vehicle travel? Since let the time be t. Let the echo be heard at time t. So this distance will be how much? S is equal to ut plus half at square. U is 0. So this is half at square. The length of the red line. This is d, and I can use Pythagoras theorem here. So I'll just mark this point here. Let's call this point A, let's call this point B, and let's call this point C. So, and let's call this point D. So AB square is nothing but AD square plus DB square, Pythagoras theorem. So AD will be 1 by 4 AT square ka whole square. DB is D square. This is your AB square. So the total distance ABC is AB plus BC. It will be 2 times of this. The root over d square plus 1 by 16a square t power 4. What is ABC here? This is the total distance traveled by sound. And how much time does this take to travel there? So the time taken t must be the total distance AB plus BC by speed of sound. Is that clear, everyone? The time taken for the vehicle to go from A to C must be equal to the time taken for the sound to go A, B, C. Both the times are equal. And what is the time taken for the sound? The total distance AB plus BC by speed of sound should give you the time. Any doubt still here? So once you got this, so you're kind of done. So they'll get T is equal to, the distance will be 2 times root over D square plus 1 by 16 A square T power 4. That's the total distance by speed of light. Square on both sides, this will be C square T square. You'll get 4 D square A square T power 4 by 16. Bring all T's to one side. That would be A square T power 4 by 4 minus C square T square minus plus 4D square. There, that's your quadratic thing. So what we can do for convenience, put T square is equal to Z. Then this guy will become A square Z by 4 minus C square Z plus 4D square. Now it looks like a quadratic equation.
It'll be Z square, right? So, and the first term.
Yeah, Z square. Now it looks like a quadratic equation. Now you know how to find the roots for Z. So Z ka roots will be C square plus or minus root over B square is C bar 4 minus 4A square by 4D square by 2A square by 4. This would be C square plus or minus C square minus A square D square 4A square D square by A square by 2. This is Z, but what is Z? T square. So we need to get our time should be positive. So I think both, there are two roots actually. We get T is equal to root over C square plus or minus root over C square minus 4A square D square by A square by 2. You get two roots. Now this we didn't expect, isn't it? We thought there's only one answer, but Max is saying, boss, there are two possibilities. We didn't figure it out. So that means this is saying there's one more possibility. See, the sound doesn't travel only one point, isn't it? Sound is traveling like this, sound is traveling like this, sound is traveling like this. Sound is hitting every point on the wall. You're getting it? The sound is hitting every point of the wall. So there is a possibility this guy is hitting 2 times echo. He can meet the sound 2 times. It's not like sound will just travel to one point. It is hitting every point on the wall. So there are two possible answers. We didn't expect that. That's what I'm saying. Even if you don't realize it, Max will take care of it. Now, if they ask you for a condition, what happens if discriminant is 0? If delta, which is b square minus 4ac, is 0. So in this case, if c square minus 4a square d square is less than 0, that is if the speed of sound is less than 2ad, what will happen? Roots are imaginary. What do you mean by roots are imaginary? Means such a time cannot exist. Means the person can never hear an echo. So he can never hear an echo. This is the condition for him not to hear an echo. If the roots are equal, you can hear the echo once. If the roots are not equal and real, you can hear the echo twice. If you get imaginary roots, meaning this guy can never hear an echo. It looks scary, but technically physics got over here, isn't it? The time taken for the vehicle to go from A to C is equal to the time taken for the sound to go from A to B and B to C. That's it. If you could figure that out, you're done. And this thing biquadratic and all looks scary, but don't worry about that. That's just plain max. Any doubts on the steps? Clear with this? So there, if you mix up little sound, you can get really some good questions. Any doubts on this? Next one, let's see one more. Let's say a little easier one. This would be a proper mains question. Let's say we have a vehicle going with u 10 meter per second. Acceleration is 2 meter per second square. The vehicle has initial speed 10 meters per second forward and acceleration 2 meter per second square backward. Find the distance traveled in 15 seconds. Let's get this. Find the distance traveled in 15 seconds. And remember, when you hear the word distance, have some fear. Get this, you got 2 minutes. नहीं परम. Right, Shriyans. Ishman, we have 2 answers. You overshot by a large value. Just to give an idea, how is this vehicle going? Speed is forward, acceleration is backward. So vehicle will go front and then come back. Hope you realized it. No, Arya, that is wrong. Siddesh, right. In the formula, S is ut plus half at square. S is not distance, S is displacement.
So there are 2 answers.
There is only one answer. Distance in 15 seconds, huh? You can't have 2 answers. नहीं रे परम. Samaya, you got it wrong. What did you do? Arya, you also got it wrong. You and Samik both got same answer, but yeah, both are wrong. नहीं होता. That is too small. Right, Arya.
Forgot to take something.
Novia wrong. Trishi right. Utsa right. 15 seconds to 10 liya. I know you took 10. Right, Novia. Let's see. Same story. The moment I ask you distance, you have to draw a picture. If you don't draw a picture, you'll not know what to do. Now, if you take the formula, S is equal to ut plus half at square. So u was 10, right side. So time is 15. Acceleration is backward. So minus sign. So minus 2 and 15 square. This will give you S is equal to minus 75 meters. Remember this. This is displacement. So at t0, right? Where are you? You're at x is equal to 0. And this particle will go straight. Remember, I always tell you, find the turning point. So when you are turning back, your velocity is 0. So if I use v square minus u square is 2as. Here your speed was 10. Acceleration was 2. This will be 0 minus 10 square. 2. Acceleration is minus 2 into s. We get s is equal to 25 meters. That means this vehicle will go 25 meters to the front and then stops and then takes a turn. And at t is equal to 15 seconds, you are at x is equal to minus 75 meters. And just look at it like this. You started at x is equal to 0 at t0, right? You can actually find this time also. That is 5 seconds. At 5 seconds, you're at x is equal to 25 meters. And then at t is equal to 15, you're minus 75. What can we conclude from here? Listen, you're at x is equal to 0. Then you went to x is equal to 25. Then you went to x is equal to minus 75. I mean, how did you travel? You went from 0 to 25 and 25 to minus 75, right? Is that making sense? So if you look at the whole path, this is how it looks. This was 25. This is 25. You came back to the origin, and this is 75. So the total distance will be, you travel 25 front, then 100 back, 25 back to the initial position, and 75 back. 125 meters. Is that clear, everyone? You always find the turning point, the point where the velocity becomes 0. Any doubts on this? All clear with this? So if I ask you a distance, this is the process. You have to draw the path, find the turning points, and then finish it off. All clear with this? Next thing. So what we did today was motion in a horizontal line. Then the next thing we have is motion in a vertical line. We'll just do the intro today. Here we have more varieties actually. So when you throw a particle in a vertical direction, what happens? We know there is a gravity. So every body on the Earth's surface is attracted by the Earth, generating a constant acceleration. Right? So whenever you're on Earth's surface, you always get a constant acceleration on the surface of the Earth. It actually changes with height, but we are talking about very close to the surface. You studied this in school. We call it acceleration due to gravity. So G, this value is around 9.81 meter per second square. For convenience, we take G as 10. So if I don't mention anything in the question, just take 10. Or if you see the options, you'll realize sometimes, 9.8, 19.6. No, there are a few things here. This acceleration here is independent of the mass. Meaning it doesn't matter if you take an elephant or if you take an ant and throw it in a vacuum, both will fall with the same acceleration. Unfortunately, real life, we don't get to see this because of air resistance. But due to air resistance, so this is independent of mass if you neglect air resistance. So air resistance does messes up things. So now before jumping into this thing, right, there are few conditions we need to see. We, study this entire thing, motion of vertical line based on certain assumptions. So first assumption, when you say up and down, what is up and down exactly? What is up and what is down? What is up and what is down? So a person standing on the North Pole. So if you say up and down like this, so this guy will say this is up. So that way, that means people in the North Pole, South Pole, what will they do? Will they walk with their heads? People on the equator are crawling on the floors. So then what is up and down exactly here? So if you look at the people on the equator, we are standing like this. People on the South Pole are standing like this. People here are standing like this. So what is up and down? So this is how we define. If you go toward the center of the earth, that is down. So the direction of net force is down. So this is down. Away from the center of the earth is up. There, that is the meaning of up and down. So when someone says what is down, it is a direction of net force. On earth, it is toward the center of the earth. We will talk about this more later on. But for now, this much is sufficient. Direction of net force. So in our chapter, we take toward the center of the earth. So toward the center of earth is down, away from the center of earth is up. So there are a few assumptions we take while solving this. The first one, we neglect any air resistance. What happens with air resistance? That also we'll study some special cases, but in some other chapter. Second thing, we neglect variation of gravity. Actually, if you start throwing really fast and really high, the gravity does get messed up, but yeah, you need really high speeds, like 3-4 kilometers per second. So we are ignoring it. We will take G as constant for most of the purposes. Third, we neglect the Earth ka rotation. Earth rotation does matter whenever you are launching, right? Missiles or anything, the Earth rotation has to be considered. Because by the time the missile reaches there, the Earth has already rotated. So if you're trying to, let's say, hit a missile with Ghatkopar station, it goes and hits Vidya Vihar, something like that. So you will get an error. And also we neglect the curvature of Earth. So we treat almost Earth as a flat surface. Because the range or whatever we get is small distances. There, with these assumptions, we solve all the problems. But if you actually look at Earth, right? If you can actually walk straight on the Earth for 8 kilometers, and if you look down, the Earth will be 5 meters below. So Earth is actually curving down. If you actually walk straight and look down, you'll be 5 meters below the Earth's surface, 5 meters above the surface. So for every 8 kilometers, the Earth keeps going down by 5 meters, kind of approximately. Clear with this? So there, these are the main approximations there. So let me show you something.
This is NASA's Space Power Facility near Cleveland,
Can you guys hear the
Ohio,
audio?
and it is the world's biggest vacuum chamber. It's used
Oh,
to
you can.
test spacecraft in the conditions of outer
So
space,
it's
and
repeating
it
two
does that
times.
by pumping out 30 tons of air in this chamber
I'll
until
post the
there are
videos in the
2
group, but
grams left. Kind of goes straight
so basically this used to be a nuclear silo, where US used to launch nuclear missiles and stuff. So NASA took it over and they made it into a vacuum chamber.
in the
So
1960s into the vacuum chamber concrete skin, which is part of the pressure form tank.
so there, so he's doing an experiment there.
Galileo
So this is where, before sending a spaceship into space, they put it here, create a perfect vacuum, and they try to check for any air leaks or how is the equipment working in vacuum conditions. So they use that for that. So you can create almost a vacuum in this entire thing. So this guy is doing that experiment. Remember, I said if you take a heavier thing and a lighter thing, it doesn't matter. They fall with same G in vacuum. So let's see what happens next.
experiment was simple.
So initially air is there,
Drop
the person is
same
still
time
inside, so
to see
let's not
which
remove
fell
the air.
fastest.
There you have feathers, you have a bowling ball. You leave them. Yeah, expected. Ball falls first and feathers come down aram se.
Now, in this case, the feathers fell to the ground at a slower rate than the bowling ball because
Air
of air
resistance.
resistance.
So that statement looks like it is wrong, that independent of mass, they'll fall.
Gravity.
So now they're closing it up, removing the air, creating vacuum.
Three hours to pump out the 8-chamber.
It takes 3 hours to empty the whole chamber.
Inside.
There.
10, 9,
They have created perfect vacuum, now they're leaving them.
6, 5, 4, cameras on, 2, 1, release.
Look at that, they're always side by side. They fall exactly at the same time. There is no difference in between their motion. They fall at the same thing. There.
Exactly. They came down exactly the same.
Exactly.
See, we always study in theory, but seeing is something else.
Feathers don't move, nothing. Look at that.
There, so I'll post that in the group anyway, so you can watch it more peacefully. So that statement which we made, right, in vacuum, they do fall at the same acceleration, is right. So if you remove the air resistance, they do fall independent of mass. You take an elephant or an ant, it doesn't matter, all will fall with G. Clear with everyone? So next class when we catch up, we'll continue from here. Then we will see the equations and stuff in the vertical direction there. So with that, we'll wrap up for the day. We'll catch up again on Thursday as usual. So any doubts, anything you can stay back and ask me. Remember, there's a test online till Thursday night, so make sure to give it. So any doubts, anything else, you can stay back and ask. Also, you're free to leave. So take care, stay safe.